has the word periodic or periods. Can someone tell me what the period is? It's not the dot at the end of a sentence. Which ones are called periods? Are they the rows or are they the columns? Column, you think? Raise your hand if you think it's the rows. Raise your hand if you think it's the columns. It's the rows. The name doesn't really matter. I don't care if you don't remember the names of the rows and the columns. That's not the important part. The important part is, what does it mean to the atom itself? So every row happens to be where the electrons can be located. They're called orbits or orbitals. Sometimes they're called shells because if you think about peeling away an onion, that's what a shell is. It's a whole three-dimensional space, and it has to be represented somehow on a two-dimensional space. And so here it is. If everyone could really focus in. So I don't want you to be surfing the internet. I know how distracting your iPad can be, but it's grade reporting week, and teachers are turning in the grades on Wednesday. And then you get to see your grades on Friday. And this is an official grade. It doesn't go on your transcript, but it's a good progress. So do a self-check, like you're a robot and you're doing a self-diagnostic. How are things running? If you have a C in the class, what's contributing to your C? Is it not turning work in on time? Staying on top of your due dates? Is it not really focusing in class? Is it not practicing your test before you take a test? So that's the important part as freshmen, that you really get to the bottom of it. I had some students come in at office hour and they wanted to see how they did on the last test, which questions they missed, so they could analyze, hey, did I just make a careless error? Am I reading too fast? So figuring that out is important. If you go to practice and your coach says, you know what, you need to stand like this. You know, when you're gonna hit the bat, hold your elbow up, you know, and let me see you take 20 swings, get in the batter's box. So that's practice, and that's analyzing why you have the results that you do. So it's important that you take the time to do that. It's a big part of learning. If you always just kind of go into a quiz and not prepare and hope for the best because it's multiple choice, I think you get a C in the class. And it's tough to get a C just by guessing. So pay close attention. I believe that if you're not paying attention in class, then you really miss out on a lot of things that are on the test. So when you look at this, the important thing is realizing that these are where the electrons are. If this was a planet, this would be Mercury, the closest to the sun. This one would be the orbit of Venus. This one would be the orbit of Earth. And then this is the orbit of Jupiter. So the farther you go down, the farther the electrons are from the nucleus, just like the planets being farther away from the sun. So keep that in mind, that these rows are the electron orbits. Now the name of the column, I think it'll stick with you. It's called a family. And didn't I mention that you're probably like your family? You might look like your family, but I'll bet you really act like your family. Like your brothers and sisters. Maybe you're a little bit more like your mom or your dad. So you kind of share the same characteristics. That's what these columns are. What do you call the gases on the right-hand side of the table? Noble. And what makes them nobility? They don't react. And the electrons are all full. So the key for an atom is to have itself stable, and the way to get there is to not have any holes in where the electrons should be. If there is a missing electron, they're going to react like crazy to get that. And we saw that in the video on how things like sodium and chlorine have one extra or one too few, and so they're really eager and easily will react with other things. So everything right in this column, they have one electron in that orbit. Especially like when you get down to lithium and sodium and potassium, they have one lonely electron. So let me draw lithium, for example. There's its nucleus, and then orbiting right here, it has two electrons shown as dots, and then it has one electron like there in the second energy level, electron. So in order to be full, it would need to gain 7 more electrons. Pretty hard to do. Or if it could get rid of this one electron, then it acts like nobility. It's all full. It's going to be unreactive after that. So everybody in this column has one electron in their orbit. Everything in this yellow column has 2 electrons. When you get over here, the last column, they are missing just 1 electron. And then when you get over here, they're full. So you see how they kind of like act alike? And the guy who designed the chart, he didn't even know about atoms. It's crazy how they can figure this stuff out sometimes without microscopes, and they're really just thought experiments. And he's just measuring things relative. This one's heavier than this one, and then he's got them by weight, and then he realized, well, but they react the same. And so he didn't know about the electrons in the orbits, but he got it right. So organizing by families is really important. All right, let's now move over to the textbook. So if you're following along with your textbook, and that would be helpful. So I'm opening up to Chapter 2, Section 3. While you're doing that, I just want to remind you that you have a quiz due tomorrow. So you realize that? Told you about the take-home open book quiz. It's on Chapter 2, Section 1, 2, 3, and 4. I've had about 20% of students take it already. So if you're waiting, you have today, and it's due by tomorrow night at 11:59. You get to take it once. You have to type the word atom to start it. So I'll show you where that is in the agenda. It's not at the assignment itself. Was that your question?
Yeah.
So there is a password that you have to type in, so that you realize that you're starting the timer and you're not doing it by mistake. So it is atom, capital A-T-O-M. So I want to go over just a few more things here because this is part of your quiz, and then we're going to get to today's lab. So we've learned that atoms were supposed to be the smallest unit of matter. That word actually means indivisible, right up here. It comes from the Greek word, and they thought that that was the smallest that you could ever get. But then they discovered that the atom itself is made up of 3 things: the proton, neutron, and electron. So you definitely need to know the subatomic particles, and then it is shown like this. So inside the nucleus, you have the positive protons orbiting like a planet, so to speak. It's not in a 2-dimensional space like a line with a planet going around the center, but it's a good way of drawing it. It simplifies it. The electrons being negative, protons being positive, and they balance out. So on the periodic table, I didn't highlight that. I think I still have it over here. They have a number, and that number isn't showing up clearly up on the board. But right up here it says atomic number. So at the very top of the box it tells you what is the most important thing for its chemical properties. That was one of the questions on the worksheet. An atom gets its characteristics from which subatomic particle? You know? Yes?
Proton.
Right, protons. So the proton in the nucleus, these red protons give the atom its chemical and physical characteristics. Its uniqueness is because of the proton. But if there are, in this example, 2 protons, there has to be 2 electrons. They balance out like that. So that atomic number, even though it by definition means protons, it also tells you how many electrons there are. So I like the math at the very bottom right here. You have 2 plus, 2 minus, and if you add those charges up, they cancel out each other, and so the atom has no charge. It's neutral. It doesn't always work out that there are the same number of neutrons, so that's coming up next on the next page. It usually is, but it can have variation in there. The mass number is the bottom number in the box. So if I were to click back over here again, hydrogen has an atomic number of 1 and it has a mass number of 1. So the mass number is 2 things. The mass is what is inside the nucleus itself. So what is there are protons and neutrons. So if hydrogen has 1 for a mass number, and it also has 1 for the atomic number, so I'll just say atomic equals 1, and that stands for protons, and they're positive. And then the mass number equals, in this case, it's 1 proton, and it is 0 neutrons. So for hydrogen, it doesn't have any neutrons. So the mass number is protons and neutrons. So if its number is 1, and we know that 1 is the atomic number, you know that's the proton. That's the only instance where hydrogen is just a proton, which is positive. This is why hydrogen becomes the key for an acid. Acids are just hydrogen ions, hydrogen plus. So when hydrogen loses its electron, it's only a proton, and that is a pretty powerful acid. Hydrochloric acid, HCl. All acids are H. They have that in there. Okay. Let's talk about isotopes. Down in this box, you can see that carbon has 6 protons, that's its atomic number, and its mass number is 12. So it has 6 protons and 6 neutrons. And then obviously 6 electrons as well. And that is normal carbon when it has a mass number of 12. But sometimes its mass will be 13, and sometimes its mass will be 14. So if you do the math, you know it always has 6 protons, but it's going to add an extra neutron, 1 extra one, or 2 extra ones. So when you look at the periodic table for carbon, its mass number is 6, its atomic number is 6, and its mass number is 12.0, I think it says 12.4. You know what that is? It's a average of all of its neutrons. So about 98% of the time it's going to have 6 neutrons. About 2% of the time it's going to have 13 for a mass number, 7 neutrons, and then maybe 1% of the time it has 8. So if you do the math, that's called a weighted average. On your report card, did you know you're going to have a non-weighted GPA and a weighted GPA? Have you heard of that? You haven't really seen a report card yet. So some people are taking an honors level class or an AP level class, and an A equals 5, a B equals 4. But typically a class has an A for 4 points, and so you earn 4 grade points for every A and 3 for a B. So a weighted average is taking into account the extra that you can earn. So same thing with an isotope. When they report all of their differences that they can have in their neutrons, then it becomes a weighted average. So that's why the mass numbers are never really a whole number. They give you the average. So if the number is really small, you know you're close. It almost always has the same number of neutrons. So the word isotope, make sure you got that in your vocabulary. That stands for an atom that has an extra neutron. And a lot of times these guys are radioactive. They give off pieces of themselves. And I'm sure you know that radioactivity is a dangerous thing because these particles that are breaking apart and leaving the neutron, it's disintegrating, giving off pieces of this energy. That can wreak havoc with our molecules, especially our DNA inside of our nucleus. So one more page to go, and the quiz is on the first 4 pages in Chapter 2. So you would want to have a split screen with your textbook. If you're on one device, do a split screen with the quiz itself and then your textbook, or if you've got 2 devices, that works out. So it has one more page about radioactive isotopes. They're harmful, but because they can be tracked, we know that they're giving off pieces of themselves. It can be useful in a medical procedure. So right down here it says that it's a tag. And if you get this in your food, now it's in your digestive system, it goes into your blood, then it goes to your different organs. They can track this with the machine. So there's a picture of someone going in there, and it looks like they're analyzing their brain. So you would drink the chemical, it would be injected into you, into your bloodstream, and then they can track where the radioactivity is. In small amounts it can be picked up and it's not going to be harmful. So definite advantage to doing this. So that's called a PET scan, positron emission tomography, and there's a scanner. And then they go on to talk about how Alzheimer's disease is when you have proteins that are breaking down in the brain and the brain stops functioning properly. There's a lot of memory loss there and a lot of confusion, so it's a type of dementia. And it's pretty much irreversible. So what they're trying to do is learn more about it. So they're studying people that have Alzheimer's, and they're now isolating different proteins that aren't in the brain. So maybe there can be a therapy, some sort of medicine technique that can help people with early Alzheimer's. So although radioactive isotopes have beneficial uses, uncontrolled exposure to radiation is always a bad thing. It accumulates. So people that work in dangerous professions, and if they have to go into an area that has spills, they'll try to wear protective gear, but they'll have a tag on themselves which shows the accumulation of all of the radioactivity that they're getting exposed to. When I found this out in my 20s, I'm like, what? Are you kidding? We have radioactive radon gas coming up through the floor in your house, and there's nothing you can do about it? So in some places in the United States, there are emissions that are coming right out of the ground. And so it's important that you realize that it's there, and there isn't a whole lot you can do about it. Isn't that crazy? It's the second leading cause of lung cancer in the United States, this radioactive gas that's just coming up from the ground. So you can, if you're a homeowner, you can buy a radon detector, and you can make sure that things are safe. And there is some technology that can minimize it. Here it says eliminate it, remove it from your home, but it's still part of the environment. I'm encouraging everyone to do the quiz. You know, I know that there are going to be some that go, oh, I forgot, or I didn't know that we had to do it. I thought it was optional. Some people will not do it because they're on a mantra to do as little as possible or something. I don't understand why you would make this your dropped quiz. So everyone, make sure you take the quiz, and there are perfect scores because you don't have to rush. Even though it's time for 1 hour, that is probably 45 minutes extra, but you have to finish it in one sitting. So make sure you take care of that. That's your homework. If I go back over here to our Canvas page, all right, I'll just launch Canvas over again and show you where the password is so that you don't lose track of that. I wasn't able to put the password in the assignment because the assignment is inside of the textbook and I couldn't add it. So it's right here in red. The password is Atom, capital A. Don't do the quotes. It's just capital A-T-O-M. All right, now let's get going with the lab for today. You'll find it over in the to-do list, or it's in the module. It's called penny surface tension. So open this up. And we are going to be using Google. We've done a little bit of work with Google Slides and stuff. This is Google Sheets. And you click on this link and it opens it up. But everyone can only view that. Right up here it says number 4. When you open it up, you have to make a copy of it. And you rename it with your last name dash Penny Surface Tension Lab. Well, it's already called Penny Surface Tension. So just move your cursor to the front, type your last name, a dash, and then hit enter, and then you save a copy of it yourself. You're going to turn in a link to the file. So you see right here, this is a link to the file. That's similar to what you're going to turn in. You're not turning in the actual file. You're turning in the online storage link to the file. So I'll show you how you do that. So you click up here and you do make a copy. And instead of having it named copy of, you go in and you'll take out that. And so anyone need help with opening up the file and renaming it? Now you'll notice that you are probably opening it up in the app, the Google Sheets app. That's fine. If you're using the website like I am, that's fine. If you're in the app and now you can't rename it, then exit the file, and then there's 3 dots next to the file name, and then rename it. Yeah, but everybody's doing their own write-up. Yeah. So everyone's going to do their own write-up? So if you look at this picture right here, it shows a water molecule. Water is H2O. I'll call this Mickey Mouse ears. So the two hydrogens are up here. They're not side by side like that. They're up here. And hydrogen, as we saw, it has an atomic number of 1. 1 proton, 1 electron. When it is sharing its electron, it does so on the line. So the outside of the hydrogen that sticks out, it's hanging its proton out there. Protons are positive. So the Mickey Mouse side of water, the ears, that's a positive. And then oxygen has got 6 electrons hanging out over here. Those are negative. So the red side of water is negative. So you can see that it shows a plus in brackets, meaning that it's slightly polarized. It doesn't mean that it's an ion. It still has the same balance of protons and electrons. They're just hanging out unevenly with water. So that makes water it's called a dipole. It has a positive side and a negative side just because of the unequal sharing or location of its electrons and protons. So if water is a magnet, it sticks to other water molecules. So if you look at the picture, the red of one sticks to the white of another neighboring water molecule. Remember when we were reading the graduated cylinder has a dip in it? Well, we don't read the sides because water, it's magnetized and it's sticking to the sides of the glass like Spider-Man hanging on the side of a building. So, or the gecko crawling up a wall with its magnetic molecular forces. So water has this magnetism to it. Water sticks to itself. And we're going to learn that because water is a dipole, it can do some pretty amazing things. So this lab is about water. And so this is a complete lab write-up, which starts with your name right up there. So you should always have a title to your pages. If I had you write this up, half of you would forget to write the title at the top. Half of you wouldn't write your name. Always have a title and your name at the top of every page. Go ahead and put your name up there. The question for the lab is water or soapy water going to allow it to stick together more? It says, how does soap affect water's surface tension? Well, when water sticks to itself and the sides of a graduated cylinder, that's surface tension. So up here in this Erlenmeyer flask, I have some blue soap in here so the water looks soapy. There's also a set of beakers at your table, and they're labeled soapy water and water. Go ahead and grab some water from the sink when it comes time to run the lab. And then when you need soap, come on up here and just pour yourself half a beaker of that soapy water. Notice that they're color coded. So blue for more like clear blue water. Don't mix up the droppers. So don't interchange them. So you have to make sure you're using the right one. So what do you think? Here's your hypothesis. It's always an if-then statement with the independent variable coming first. If I do this, then you talk about your dependent variable. So what do you think will happen? If I add soap to water, then it will increase or decrease the water surface tension. Write in your guess. A hypothesis is meant to be written before you run the experiment, not after you get your results. So right now, under hypothesis, fill in the sentence. If I add soap to water, then it will increase, decrease, or keep it the same. Let me say, if I add soap to water, then it will increase the water surface tension and allow for more drops to fit on the head of a penny. So you're going to take a penny, and if you choose to do the head side, then always use the head side. Don't sometimes switch to the tail side. Just keep it the same. If you choose tails, use tails the whole time. So then you'll do the pure water first. You'll fill this dropper up and then you have this on the table, it might be a good idea to get a paper towel off of the wall there on the paper dispensers. And don't squirt it, but 1 drop at a time, and you're counting how many drops. It will keep piling up, and at some point it's going to spill over. And that last drop doesn't count, that made it spill. And then record down in here what the number is. These numbers are just a placeholder. It's going to automatically do the formula for you. So let's say that it was 10. Then I'll just go in here and type 10. And then I do it again. Probably a good idea to dry the penny off. Start with a dry one. And then maybe the next time it goes 15. And then maybe the next time 50. No, I wouldn't expect to have that big range like that, right? But sometimes people write down the strangest numbers that a student made an error on, and then this is called an outlier. You got to look at that like, oh my gosh, did they make a mistake? Are they using a different coin? So we're trying to keep everything the same. If you notice that some number just doesn't quite fit, then you might want to double check it. So those are the directions. I was just paraphrasing it. Then you go back and you do it again with the soapy water. All right? So this is already all built for you. You can see that it is automatically making this as you type in the data. So this is something that you should be able to build yourself too with formulas. We learned how to do formulas with the Numbers app, but this here in Google, the same thing. The menu system's just slightly different. So this is a skill. Everybody has to do this lab on their own. You're just typing in numbers. It's pretty easy, right? And then you have some conclusion questions to answer down here at the very bottom. So how do you turn this in? You don't turn the file in. You're going to turn in a link to your file. I'm on the website, so I click on Share. And then it's just copy the link. I'm back at Canvas. If you're using the app, then you hit the word share, and then you get this menu. You might have to make sure that you have sharing turned on. Did you know that you can give someone the link, but they can't open your file? So you have to give the permission for someone to open it up. If you use the website, they do a nice job of saying, hey, if you are going through this menu, we understand that you want to share it, so they open it up. But if you're using the app, it's a two-step process. And so number 6, I just said if you're using the app, make sure you turn it on. Otherwise, you gave me the file, but you left the door locked and I can't open it. All right, so now you can go to a lab table. You can kind of see that there's a setup for 2 people, 2 groups at each table. I'll come around with the video.